In this section, we start our work with logarithmic functions, and I just want to preview the section by showing you the definition. Here's what's going to be new. Y equal logarithm base b of x. That's the new expression, and it's equivalent to b to the y equal x. So this expression and this expression are always exactly the same thing. We have this restriction that the base b here and b here has to be a positive number other than 1. Okay, so y equal logarithm base b of x, that's how we say this. This is what it means. B to the y is equal to x. So this is new, it's unfamiliar to us. Here's some exponential kind of notation. It's more familiar to us. So a lot of times when we see this, what we do is just translate it into this and do the work. So what is this y right here? Y logarithm base b of x. Well, y is an exponent. Logarithms are exponents. This is the exponent I need to put on b in order to get x. So when I see this expression, what I say to myself is, this is an exponent. It's the exponent I need on this base to get this number right here. So in any case, that's the definition. Here's the restriction on that. And then this is what it looks like in terms of natural logarithms and natural exponential functions. Y equal natural logarithm of x, the base e is implied here. So we don't write the base e because this happens so often that, and comes up so often in mathematics that we just use a little shorthand notation. So this stands for logarithm base e of x, where e is that number we saw from the previous section. The limit is x goes to infinity of 1 plus 1 over x to the x. That whole limit right there, that's the number e, and that's the base right here. Well, if I follow this kind of reasoning, y equal natural logarithm base e of x, if and only if e to the y is equal to x. So this is the exponent I must put on e in order to get x. So this and this are equivalent. Look what happens if I want to find the inverse of this function right here. If I want to find the inverse of this function, all I do is exchange x and y. If I exchange x and y, what do I have? Y equal e to the x. So y is equal to e to the x. That's the inverse of this function. But this function is equivalent to this function. That means that y equal natural log x and y equal e to the x are inverse functions. These functions right here are inverses of each other. Now don't be confused between this and this. This is equivalent to this. These are the same expression. But if I interchange x and y in this function, I get this function. That's the inverse of this function, but this function is equivalent to this one, so this must be the inverse of this. So that's the relationship between our natural exponential function that we saw in the previous section and this new function, this natural logarithm function that we're going to see in this section. So in any case, a little introduction to that section on logarithms. First, the definition, and like we said, these definitions are getting a little more abstract and a little more complicated, but all we do is accept them. When we see this, what does it mean? There's no easier way to say it. It means this right here. So that's the definition. Here's some consequences of it, and that's your introduction to the section on logarithms.